Hello friends, I am Vidya Patil, Assistant Professor, Department of Mechanical Engineering in Sharad Institute of Technology, Polytechnic, Yadra. Today we are going to continue our third unit of air compressors for the subject Power Engineering and Refrigeration. Today in this session we are going to cover the compressors terminology, rotary compressor, screw compressor, lobe compressor, vane compressor, centrifugal compressor, axial flow compressor, and comparison between reciprocating and rotary compressor, and comparison between reciprocating and centrifugal compressor. We start from compressor terminology. In compressor terminology, we see the intake pressure, discharge pressure, compression ratio, that is also called pressure ratio, compressor capacity, free air delivery, and swept volume. Okay, we see one by one. First is the intake pressure. Intake pressure is the pressure at which the air is taken in the cylinder of compressor, that is at entry pressure. And discharge pressure is the pressure at which the air is delivered by the compressor. Okay, as enter, that is intake pressure, and delivered, that is discharge pressure. Third is the compression ratio, that is also called pressure ratio. This is the ratio of delivery pressure to the suction pressure. Okay. Next is the compressor capacity. Compressor capacity is the quantity of the free air which is actually delivered by the compressor. Okay, quantity of air which is actually delivered by the compressor, and it is measured in meter cube per minute. Next is the free air delivered, that is also called FAD. Okay, FAD, it is the volume of air delivered under the conditions of the temperature and pressure existing at the compressor intake. And in the absence of these free air conditions, these are taken as STP conditions. In STP conditions, the pressure is taken as 1.01325 bar, and pressure and temperature as a 15 degree centigrade. Okay, that is free air delivered conditions are taken. Next is the swept volume or piston displacement. In actual volume of air taken in during suction stroke, it is expressed in meter cube, but swept volume when expressed in meter cube per minute, that is also called piston displacement. Okay, this piston in mathematically, this swept volume is given as Vs is equal to pi by 4 d square L. Okay, where the d is the small d is the diameter of the cylinder bore in meter, and capital L is the length of stroke in meter. If the compressor runs with the speed n rpm, then this piston displacement is equal to pi by 4 d square L into capital N, and it is measured in meter cube per minute. That means only N is added in the formula of swept volume. Okay. Next, now we see the rotary compressors. Okay, in this lecture 1 for the air compressor, we already see the classification of air compressors, and after here again we see the classification of this rotary compressor. In rotary compressors, there is a rotary air compressor having the rotating element to compress the air, and it supplies the air at low pressure, but it gives the continuous discharge with large quantity of air. Okay, these rotary air compressors are classified into two groups, that is positive displacement compressor and non-positive displacement compressor. These positive displacement compressors having two sets of mutually engaging surfaces, and air is trapped between these lobes, and due to the sequencing action and backflow of air, pressure rise is observed in positive displacement compressor. For example, root blower and vane blower. Okay, and here we see root blower, vane type, Lisham compressor, and screw type compressor. These are the positive displacement compressors. And next is the non-positive displacement. In non-positive displacement, the pressure rise in the compressor is not due to the space reduction or backflow of the air, but it is due to the transfer of kinetic energy into pressure energy, and due to the arrangement of impeller and fixed ring. Okay, these compressors are also known as dynamic compressors, and here the non-positive displacement compressors are centrifugal compressors and axial flow compressors. Okay, now we see one by one compressor. First we see the screw type compressor. Okay, in this figure we can see there is a figure number 1. There is a screw type compressor. There are two rotors, that is first is a female rotor that is driven, and second is the male rotor that is driven. Here in a screw type compressor is a positive displacement compressor, and it consists of two mutually engaged helical grooved rotors that is suitably housed in a casing. And out of these two rotors, generally main rotor is a driver rotor, and having this rotor there are four helical lobes, and which is engaged in corresponding fluids of that female rotor. Here we see that is female rotor, that is driven rotor, and has 6 number of fluids. That means male rotor having 4 fluids, and female rotor having 6 fluids. Okay, both are engaged, and during the rotation of this rotor, air is drawn through the suction port to fill the space between male and female rotor lobes. Since the air drawn between the lobes is isolated from the suction port, and this air so trapped is moved both axially and radially, okay, with the rotation of the rotors compressed, and due to the volume of reduction. When this compressed air is put in communication of discharge port, and air leaves through this discharge port. Okay, here we can note that this male and female rotor rotates at different speed due to their different number of lobes and fluids. Okay, here this screw compressor is capable of handling 3.5 to 300 meter cube per minute of air with a maximum pressure ratio of 20. Okay, here but there are some advantages also. This screw compressor are this screw compressor having high volumetric efficiency and is obtained as there is a practically low clearance volume, and this is our uniform and continuous airflow is obtained, and also the absence of suction and discharge valve, this eliminates the pressure drop here. And in this screw compressor there is a partial load. At partial load the power consumption is less, and it can be directly coupled to the prime mover. And also this screw compressor is used with refrigerant R22 and ammonia, and having it even torque and purely rotary motions, therefore it is perfectly balanced compressor. Okay, next is the lobe compressor, that is also called roots blower. Okay, in this figure we can see in figure number 2 there is inlet pressure P1 and delivery pressure P2, and inlet pressure having low pressure, and after that is entry of the reservoir there is a high pressure. Okay, and here in figure number 3 we see in PV diagram of this roots blower. First we see the construction of that. There it consists of two rotors which are driven externally. Okay, and one of the rotor is connected to the drive, and the second one is a gear and driven from the first. The rotor have got 2 or 3 lobes having epicycloid, hypocycloid and involute profiles. This high pressure delivery side is sealed from the low pressure suction side at the angular positions. Here there is a very small clearance is maintained between the surfaces to prevent the wear. Air leakage through the clearance decreases the efficiency as the pressure ratio increases. Here we can see during the rotation volume of air, that is V, at atmospheric pressure P1 is trapped between the left hand rotor and the casing, and this air is positively displaced with the change in volume until the space is open to high pressure region. At this instant some high pressure air rushes back from the reservoir, and mix irreversibly, okay, with blower air V until the pressure is equalized. Here in this figure we see that here the reservoir to be infinite size is assumed and the pressure is equalized to the reservoir pressure P2. The air is then delivered to the reservoir, and this happen 4 times with the 2 lobe rotor and 6 times with 3 lobe rotor. Okay, that means it is depend on the number of lobes of the rotor. Here, therefore, the free air delivered of 2 lobe rotor is 4 into volume, 4 into V per revolution, and it should be noted here that the work done per revolution of a rotor WD is equal to P2 minus P1 into 4 times volume. Okay, here in PV diagram we see here there is 4 to 1, that is suction, that is swept volume Vs, and 1 to 2, that is irreversible pressure rise due to backflow from the reservoir, and 2 to 3, that is delivery. Okay, here now we see the roots blower is having pressure ratio 1 to 2 and the capacity around 8.5 meter cube per minute with the speed of 250 rpm. Now we see the vane compressors. Okay, vane compressors in figure we see there is a rotor and casing, and in casing there are number of vanes, and spring is also situated in vanes, and here it consists of 2 rotor located eccentrically in a cylindrical outer casing, and the rotor carries a set of spring loaded vanes in the slots of the rotor, and also the volume of the air V1 at atmospheric pressure P1 is trapped between these 2 vanes. As the rotation proceeds, the trapped air is first compressed reversibly from condition 1 to D. Here in PV diagram also we can see from 1 to D, and compressed reversibly from 1 to D, and the compression takes place due to the decrease in volume provided for the trapped air. Here we can see from 1 to D there is a decrease in volume because of trapped air, and then air is compressed irreversibly from the pressure PD. Okay, and to deliver pressure P2. Here PD to delivered pressure P2 we can see here in PV diagram. The irreversible compression is similar to the compression explained in root blowers also, and the vane type compressor requires less work compared to roots blower for the same capacity and pressure rise. Here normally vane type compressors are used to deliver up to 350 meter cube of air per minute at a pressure ratio up to 4, and the speed of the vane type blower is limited to about 250 rpm. This vane type and roots blowers are replaced by centrifugal compressors for their use in supercharging aero engines. Okay, and this is because the centrifugal blower are completely much more efficient, can be easily fitted into the design of the aero engines, and can be driven at much higher speeds, and are much more efficient. Okay, now we see the centrifugal compressor. Okay, in this diagram number figure number 5 we see there is a centrifugal compressor. Here they are mainly used when large flow rate of refrigerant and small pressure ratios are required, and it is generally preferred with refrigerant having large specific volume. Okay, these centrifugal compressors consist of rotating member, rotating member is known as impeller wheels that are mounted on steel shaft and enclosed in cast iron casing. Okay, this impeller wheel consists of 2 discs, and hub disc and cover disc with a number of blades mounted radially between them, and impeller blades are constructed in stainless steel to avoid the corrosion and erosion, and an impeller has rotary vanes also, which provides closed radial passage for flow of air, and atmospheric air is sucked in the center of the impeller, that is called eye, and a diffuser ring around the impeller is provided with diffuser vanes. Okay, in a diffuser vanes, this kinetic energy of the air changes into pressure energy, and the volute casing also provides diffuser passage for the further build-up of the air pressure. As the impeller rotates at a high speed, air undergoes a centrifugal action and is accelerated to a high velocity, and the air is decelerated in the diffuser and volute casing to build its pressure. Finally, the compressed air leaves through the outlet. Here we can see there is a compressor air delivery or outlet. This type of compressor supplies air usually in the pressure ratio range 1.1 to 2.4 and maybe up to 4 when it is single stage compressor. Okay. In case of increasing stage on a same shaft called multi-staging compressors also, and the pressure ratio obtained range from 11 to 15, and such type of compressors are used in turbojet engines and even furnaces and for pipeline flow and for supercharging of IC engines. Okay, these centrifugal compressors handles large volume of air, and also speed is very high due to the perfect balancing, and due to the perfect balancing, centrifugal compressors is free from vibration and noise, and there are only few parts of this compressor. That's why that is shaft and bearing requires lubrication, and the efficiency of this centrifugal compressor is high, and part load efficiency of centrifugal compressor is better than the other compressors, and also directly coupled to the motor or prime mover, and it can be conveniently used with R11, R12 and R13 and ammonia. These refrigerant are used, but disadvantage of that centrifugal compressor is that the main problem is the compressor surging, and pressure ratio per stage is smaller, and in multi-staging of compressor is difficult part. Okay, this is all about centrifugal compressor. Now we see the axial flow compressor. In figure we see axial flow compressor. There is a air intake from one side and compressed air at other side, and at the middle there is a rotor and shaft, and the fixed blades are situated in casing, and moving blades are also fixed and moving. Two types of blades are situated in casing. Okay. In axial flow compressor is a multi-stage unit, as each stage built up pressure by a small amount, and the unit consists of a ring of fixed blades and ring of moving blades. The function of fixed blades is to receive the high velocity air from the proceeding rotor blade, and it to direct the flow to the succeeding row of rotor blade. Okay, and moving blades are mounted on the rotor, while fixed blades are fixed on the stator or casing, and the blades are aerofoil shape for efficient working. This airflow through the annulus ring between the rotor and the stator over the blades parallel to the axis of the compressor. Here, as the rotor rotates, air in the blades passage accelerate, due to which the velocity and pressure increases, and the air then passes through fixed blade passage of diffuser shape, and in which the velocity of air decreases and pressure increases, and pressure rise in each stage is of order 12 to 15 percentage, and the number of stages used vary from 5 to 14, and it can handle air up to 30,000 meter cube per minute, and it is mainly used in gas turbine plants. Okay, this is all about axial flow compressor. Now we see the comparison between the reciprocating and rotary compressor. These reciprocating compressors, the compression of air takes place with the help of piston and cylinder arrangement, and with the reciprocating motion of the piston, and in a rotary compressor the compression of air takes place due to the rotary motion of the blades, and the delivery of the air is intermittent in a reciprocating compressor, and and delivery of air is continuous in rotary compressor. The delivery pressure is high and pressure ratio is also high in a reciprocating compressor, and delivery pressure is low and pressure ratio also low in rotary compressor. Also flow rate is also low in, but here the opposite, that is flow rate of air is low in a reciprocating compressor and flow rate of air is high in rotary compressor. Also the speed of compressor is low because of unbalanced forces, and the speed of compressor is high because of perfect balancing in rotary compressor. In reciprocating air compressor has more number of moving parts and it needs proper lubrication and more maintenance. And also in rotary air compressor has less number of moving parts and therefore less maintenance is required. Here in a reciprocating compressor, due to low speed of rotation, it cannot be directly coupled to the prime mover, but it requires a reduction of speed. But in a rotary compressor, rotary air compressor can be directly coupled to the prime mover. Reciprocating compressors used where the small quantity of air at high pressure is required, and rotary are used when a large quantity of air at lower pressure is required. Okay, and maximum delivery pressure in reciprocating compressor is as high as 1000 bar, and rotary having only 10 bar only, and maximum free air discharge is as high as 300 meter cube per minute, and maximum free air discharge is as high as 3000 meter cube per minute. That is too high. And the size of the compressor is large for a given discharge, and size of the compressor is small for the same discharge. And air delivered is less clean as it comes in contact with the lubricating oil in the reciprocating compressor, and air delivered is more clean as it does not come in contact with the lubricating oil. And also isothermal efficiency is used for all sorts of calculations in reciprocating compressor, and here in rotary compressor only isentropic efficiency is used for all sort of calculations. And in a reciprocating compressor, due to low speed of the rotation, it cannot be directly coupled to the prime mover, but it requires reduction of speed, and in a rotary compressor they are directly coupled to the prime mover. Okay, now we see the comparison of this reciprocating compressor and centrifugal compressor. In reciprocating compressors having poor mechanical efficiency due to the large sliding parts, and centrifugal compressors having better mechanical efficiency due to absence of sliding parts. The delivery of air is intermittent in a reciprocating compressor, and delivery of air is continuous in centrifugal compressor. Also there are some parameters like adaptability, that is to low speed for the reciprocating compressor, and for centrifugal compressor there is a high speed. And reciprocating compressor are suitable for medium and high pressure and low medium gas volume, and also used for small mass flow rate required at high pressure. And for centrifugal compressor are only suitable for the low and medium pressure and large gas volumes, and also used for large mass flow rate at lower pressure. The mechanical efficiency is low for the reciprocating compressor and high for the centrifugal compressor. And also the capacity of delivering volume is a small volume for the reciprocating compressor and a large volume for the small volume for the reciprocating compressor and a large volume for the centrifugal compressor. Okay, in this session we cover all the types of rotary compressors. In next session we see the various types of problems, so we solve the problems related to this session, that is rotary and reciprocating compressors. Thank you.